Hello, today we're testing one of the amplifiers from the Robinson machine at Bletchley Park. There are two amplifiers on the whole Robinson machine. This is one of them. It's got 13 amplifiers in it and 40 valves. Now we're testing it today for the first time, and I'm very pleased to say that there's been no smoke and no flames. We've got 7 power supplies. We've got a 400 volt power supply just out of shot, plus 150, plus 125, plus 50, 12 volts for the heaters because the valves are running in series pairs, and another 12 volts for two of the valves which must have an isolated heater. To do the testing we're going to use this, a little device I made. It's got a microchip pick inside it, and it generates the signals that would come off the tape, the punch tape running on the bedstead. So let's plug this in and see what happens. Now looking at the scope, I'm going to show you all the various channels and what they should look like. We're looking at the signals on this Regal DS1104 scope. Now it's a 4-channel scope, but we don't need all 4 channels, just one will do for us today. After all, this machine was designed in 1942. The signal it's showing at the moment is one of the start and stop signals. On the 5-track tape there are 2 channels punched specially off the line of the 5 channels, one's to start and one's to stop. This is the start, this is the stop, and they're a negative going pulse, normally up at 5 volts. When they go low, that means the event's occurred. So they look okay. We'll now look at the 10 data channels. There's number 1. Now they look a little bit jumpy, but that's alright. It's because they're not constant. There's the starts and the stops appear now and then, and that causes that jumpiness. But that's a nice signal. Good square edges. Number 2, number 3, number 4, 5, 6, 7, 8, 9 and 10. So nearly everything's working alright. There's one more thing to check, and that's the sprocket output, and that's a bit smaller. So we'll turn the scope up there. These are the sprocket pulses, and they're much narrower because the sprocket holes are a lot smaller. The sprocket amplifier also does some rather special stuff which we can't go into now, but it gates the starts and the stops as well. But that's the testing procedure over. We're happy that the amplifier works. The next thing to do is get it on the machine, get the machine finished and get it running, which shouldn't take that long now. We're in the middle of 2014. We're hoping to have it running. So to end all good testing, you should really make a note of the equipment you've been using. The main power supplies we've used today are made by Kikusui. This is a rather older model. The power supplies up here supplied 125, 150 and the minus 12 volts. And finally, this beautiful power supply here is a Kikusui PCR 2000M. It's a 2 kilowatt unit, and I'm taking 14 milliamps from it. It doesn't mind, but it's an AC source or a DC source. And all this testing's happened at my colleagues' Telonic instruments, and I'd like to thank them very much for letting me do this. Thanks guys.